California group. This is a California group, and you should know that, you know, a lot of this technology and a lot of the computing technology and storage speed and power was really, you know, comes from all of the great work of the engineers of the Bay Area. So there's just a lot of Bay Area in this story. So before I talk about our technology, I know this group knows these facts and knows these statistics, but just, you know, just to remind you that detecting cancer earlier can dramatically improve cancer survival. This is data from that cancer registry that I used to work for, CER, the National Cancer Registry Program. And this just shows you what is a 5-year cancer-specific survival rate when you diagnose cancer early. It's up in the 80–90%. Once cancer has metastasized beyond the organ of origin to other parts of the body, survival is much, much lower. So we know that there's very little we can control about cancer. We can't control if we get it. We can't control what kind we get. But one thing we may be able to do something about, and we're going to unpack this, is try to diagnose it as early as possible so that we can, of course, intervene with surgery and other kinds of treatments. One thing you may not think about is the proportion of all cancer deaths that we're doing absolutely nothing about. So again, courtesy of my perspective of monitoring cancer in the large population of the Bay Area, we should really not be thinking about cancers one at a time. We should be thinking about populations and what kind of the full range of cancers that any population will inevitably develop. So at this time in the US, we have the following breakdown of cancer deaths. We have about 30% that are attributable to cancers for which we do have guideline recommended screening. So I'm sure most of you know this, but I'll just give you a quick refresher on what kind of guideline-based screening programs we do have available in the US at this time. We have mammography for breast cancer. We have cervical cancer screening for cervical cancer. We have all different kinds of colorectal cancer screening, including colonoscopy to remove precancerous lesions, as well as other fecal tests to detect the presence of cancer. We now have a DNA-based test, Cologuard, that you can use to detect colorectal cancer from DNA in feces. We have lung cancer screening, but it's only a proportion of the population is eligible for lung cancer screening. LDCT screening for lung cancer, which is a pretty robust imaging based screening, is got a fair amount of harm due to false positives, and as such is only available to people who have a very particular smoking history. And so therefore lung cancer screening only covers about 30 to 40% of all lung cancers, because not everyone is eligible for lung cancer screening. And we all know that about 20% of all lung cancer occurs in people who never smoked at all. So only a proportion of lung cancer is eligible for screening. And then prostate cancer screening is no longer recommended routinely for the general population in this country. It is available from talking individually to a doctor, but all in all, we estimate that of all cancer deaths, about 30% are occurring to cancers that we are trying to do something about the stage of diagnosis and moving it earlier, leaving 70% due to cancers that have absolutely no screening. And that's just an enormous percentage of the cancer burden that's attributable to the cancer types you can see on the screen that really have nothing available for people. And we just consider that too much. So again, just stepping back and looking at the big picture, looking at all cancer, and we know that, again, that any population, people are going to go on to develop each and every type of cancer, including the common ones and the rare ones. And then when we're looking for cancers one at a time through these guideline recommended screening programs, we're only hitting about 30% of cancers. If you are a non-smoking male, over the age of 50, we're only screening you for one cancer technically right now, and that's colorectal cancer. So the big picture we really step back and look and think, wow, there's just a whole lot of, cancer deaths that are occurring without any proactive means of earlier detection. And that was really the kind of inspiration for coming up with a better way. So let's talk about what that is. Sorry. So again, a really interesting observation made in recent years, and this was enabled again by the ability to sequence all of the DNA floating around in your blood. But this is what it looks like, and this is how it works. So all of the cells in your body, and in this graphic, we can see the normal cells are coded as blue, and the cancer cells are coded as tan. All cells at all times are turning over according to naturally scheduled apoptotic processes. And when they do that, they dump their chromosomes and all of the DNA that are contained in the cells just into your blood, and it circulates. So therefore, at any given time, a blood sample taken from the circulating blood has a referendum of what's going on with the DNA in your body. So if you do have a tumor, as you can see in this picture here, the hypothesis was if we sequence all of that DNA and we look for a pattern, we look for a copy number of types of mutated DNA, maybe we can find a signal. So there was this kind of really big idea back in the early 2000s, and then here is where we started to realize that it might be possible. The first application of this technology of sequencing all of the DNA in your blood actually was developed for pregnancy. So you may have heard of this product, but there's a product called NIPT, non-invasive prenatal testing. Back in the old days, including when I had my children 18 and 16 years ago, a high-risk pregnant woman would have to undergo a procedure called amniocentesis to take a little bit of the amniotic fluid to test it for the baby's cells and to understand if there were any genetic abnormalities. More recently, in the 2000s, somebody realized that the placenta was shedding the baby's DNA into the mother's blood, and that if we could just take a maternal blood sample and separate out the DNA from the mother and the baby, we could look at the baby's DNA, and instead of subjecting the baby to this dangerous procedure involving a needle in the amniotic sac. So this product was very rapidly uptaken. Virtually all pregnant women who wanted this screening obviously chose to have that done through a maternal blood sample as opposed to amniocentesis. And the company Illumina had done about 300,000 or 400,000 of these tests, and they had some very interesting findings in their commercial lab. They had women that they wanted to give results back to, but their samples did not pass quality control. Their samples were contaminated, and they couldn't understand why these women's prenatal tests weren't working. And they started talking to the doctors of these women, and they learned that these women had gone on to be diagnosed with cancer. So there was not only the baby signal and the mother signal in the blood, but there was an interfering signal, and that signal was coming from a cancer. And very interestingly, it wasn't just one kind of cancer. It wasn't like breast cancer only, or it was all different kinds of cancer. It was lymphomas and breast cancers and lung cancer and all different kinds of cancer. So basically this observation led Illumina, the company that was running these tests, who also makes the sequencing machines that does all the genetic sequencing for these kind of tests, and realized that there is probably a common cancer signal in circulating DNA, that women that had cancer and got this test had a certain genetic profile in their blood that was flagging that cancer. And this was a really profound scientific kind of insight. It was published in the New England Journal. It was published in JAMA in 2015. And what happened was the company that was, running these tests and also owns the sequencing machines, Illumina, which is based in San Diego and in the Bay Area. There's a big building right on the other side of the 92 on the Foster City side, if you've ever seen it. they decided we need to start a new company to explore this possibility of early detection through cell-free DNA-based blood tests. So that company is called GRAIL, and that's the company that I worked for. And I heard about this new company and this possibility in 2016, right after they started the company. And for me, it was like falling in love. I was like, I heard the story and I was like, that's it. I'm giving up my academic career and I'm going to go help with this effort, because I just thought it was so exciting. So fast forward a little bit, and I don't know if any of you were paying attention to the news this week, paying attention to ASCO, which is the big annual cancer oncology conference that occurs in Chicago, where many new treatment innovations are scientifically presented for the first time. But I was there, it was in Chicago. There was huge coverage of, all of these different applications of this cell-free DNA-based strategy for monitoring cancer. So I just wanted to show you that it's really this same signal that we are tracking. In this little graph, you can see that, we're imagining that this is what the graph of a cancer shedding a signal of cancer DNA into the blood might look like, and that in the early detection phase, we're trying to catch it before that cancer has started to cause any kind of symptoms. We also have efforts that are we might call it late detection, in people who are developing symptoms of cancer and coming to their doctor and saying, hey, I don't feel so good. But as we all know, there can be a substantial diagnostic odyssey in people that have vague symptoms of cancer, such that it still takes a very long time for that cancer to get diagnosed. We think that this signal could be very helpful in speeding that resolution, speeding that diagnosis along. And there are products and programs in this space as well. As soon as a cancer is diagnosed, we hope that, that cancer starts to get treated. That's this peak here. And then, the signal, as the treatment is effective and is killing off those cancer cells, we expect that signal to reduce back down to zero as the cancer is killed. And then you may have heard of this idea of MRD. There are companies that already have products in this space for monitoring minimum residual disease. So for monitoring that cancer that might be, either has totally responded to therapy. We hope we'd like to see that tumor signal stay really low. But if it starts rising again, then we know that treatment might not have worked, and we want to have the earliest possible read on that. So for early detection of recurrence or any residual disease, we think that this signal will be helpful at all. And then as a cancer relapses, we would think that the signal would go up again. So there are many, many companies, many academic programs that are working in this entire cancer continuum on what we can do with these cell-free DNA-based tumor DNA signals. And it's just a really, really exciting time, because you can see how not only if we're catching a cancer earlier with the early detection products, and then we can, effectively surgically resect the tumor and give adjuvant therapy. And we all know that there's so many exciting immunotherapies, like the stuff that was published all over the newspapers earlier this week at MSK, of immunotherapies and targeted therapies that are really getting great results when cancers are diagnosed early, before they've metastasized. And then now we're able to track early and understand whether or not a treatment is working or not, and swap out that treatment or otherwise, change the playbook. So I just wanted to show you that this is, I'm going to talk about the early detection space right here, but this same signal is super exciting and interesting across the entire cancer spectrum. So back to, this part of the picture, which is early detection, which is, logistically and probably technically the biggest challenge on this entire sheet, like how to detect cancer early in people that have no idea that they have cancer, that do not have any symptoms. What is the strategy there? So we started the company in 2016. We actually started thinking that we were going to draft right behind mammography and colorectal cancer screening and all the established single cancer screening approaches that we have, and we could just add a blood test. But when we got our first results back from our study, and I'll talk about how our studies were organized, we realized, no, the real opportunity is to create an entirely new paradigm, an entirely new approach to cancer screening. And since we think that virtually all cancers have the possibility of shedding the signal into the blood, we need to test people one time for as many cancers as we can, instead of picking and choosing and just saying, look, we're going to look for this one, because any given person who doesn't have cancer or doesn't know they have cancer yet is at risk of developing any kind of cancer. So why would we pick and choose one? So that's the real difference between the MCED, multi-cancer early detection, or multi-cancer screening approach from, the status quo that we're doing now. For now, we look at one cancer at a time. In this approach, we're detecting as many cancers as we can at one time. So it's really important to understand that, especially I referenced colorectal cancer screening and cervical cancer screening as super important existing evidence-based proven screening approaches, because they remove precancerous lesions like polyps and dysplastic cervical tissue. So we do not seek to replace any recommended single cancer test. We are just looking to add on to that and to complement what's already being done that we know is working. Together with our blood test and the existing single cancer screening, we can optimize and now kind of think about overall cancer detection in the population. So now we're moving away from evaluating these tests one cancer at a time and saying, look, these just affect breast cancer or colorectal cancer, and we can think about how are we optimizing detection overall in the population. Of course, any of these approaches, it's crucial to minimize the harms. And the major harm from these tests, these are blood tests, and they're screening tests. So they would lead to a recommendation for an imaging test. If you get a positive test on our test, the next step is almost always imaging, right? For where we think the cancer is coming from. But we have to minimize any kind of false positive that would subject you to those diagnostic workups that are useless. So minimizing the harm. So let's look at how that works. So one thing that's really exciting about my company's approach, my company was spun out of Illumina, as I said, in 2016, and had the great fortune of raising a lot of money from venture capitalists. So we raised almost $2 billion from the venture capital community because, as you can see from this slide, we knew that the kind of studies that we would need to do to understand this approach were going to be massive. They were going to be much, much bigger than you see any other clinical trial for a cancer treatment, for example, because we need to enroll healthy people, for the most part, healthy people that only a tiny proportion, 1 or 2%, are going to go on to develop cancer in the course of the study. So all of our studies, as you can see here, have incredibly large size. So I'll just tell you a little bit about our approach, but I will point you to our website, which is www.grail.com. And there is a publication tab on there, and you are welcome to download and read and look at any of our publications describing these studies. Many of these studies are in process and they're not completed yet. Some of them are completed. So the first study we did, and we have totally completed this study in terms of enrolling the patients, is called the Cell-Free, CCGA, Cell-Free Cancer Genomic Atlas. And that atlas word, A, was a really important word. In this study, we found a whole variety of patients who had been developed with each and every cancer type. We really looked for all the different kinds of cancer types, in the last couple of weeks. And we said, you've just been diagnosed with this cancer. Will you enroll in the study and give us a blood sample so we can look for the signal that might be shed by your type of tumor? So with this atlas of blood samples from a variety of both cancer patients and people who did not have cancer. So we enrolled people who were at the hospital anyway for some other reason that we did not think had cancer, and asked them to give a blood sample. And importantly, we asked people that had pancreatitis or Crohn's disease or some other kind of inflammatory condition that might be mistaken for cancer, because we wanted to make sure that our cancer test has as few false positives as possible. So in this In this study, we enrolled newly diagnosed patients and control patients who did never have cancer. Of course, those control patients who never had cancer, about 1% of them per year go on to develop cancer. So those are extremely interesting patients because we enrolled them when they did not know they have cancer, and then they went on to develop cancer. That's our first huge study of over 15,000 patients. Our second and third studies are called cohort studies. STRIVE is almost 100,000 women who were asked to give a blood sample at the time of their regularly scheduled mammogram. And we are tracking all of those women forward in time to learn which ones develop cancer. And that study will be completed in 3 or 4 years. Summit study is near and dear to my heart. We wanted to look at lung cancer screening, but in the US, we have very poor uptake, and we decided to go to somewhere that has nobody's getting screened for lung cancer. We went to the National Health Service of the UK. So we went to London and we set up an LDCT machine, and we invited people who are eligible, have that high smoking history, at high risk of lung cancer, and we asked them to give a blood sample at the same time as their screening to understand how this test would complement that screening. That study, unfortunately, was cut short or cut down due to COVID. We meant to enroll about 30,000 people into the study, but because COVID hit it right in its prime enrollment period, it's 13,000 people, but it's still a very enormous study of individuals at high risk of lung cancer. Pathfinder is a study that we are wrapping up. It was a 1-year study of the blood test that we developed from the CCGA study, which I'll talk about exactly what it does in a minute, but we wanted to learn if it was safe. We basically just wanted to make sure that it didn't cause any diagnostic odysseys. And we enrolled 6,000 people all over the country a couple of years ago, and we used the test and gave them results back in real time to make sure that the test was safe and that clinicians could get an answer of what cancer it was and that the test actually worked, but it was too small to really understand exactly how it works. The next study, which is the most important study, is called a randomized controlled trial. And I'm sure this crew knows exactly what those are. Those are huge studies where you take a bunch of people and you randomize them when you enroll them, and you tell them some of them get the test and some of them don't. So we have done that in the National Health Service of the UK. We started that study about 15 months ago, and we've been working so hard, and we'll be excited to announce in a couple of months that we have fully enrolled 140,000 people ages 50 to 77 in that trial, and half of them are getting the test and the other half are giving blood samples that are going in the freezer. And we will be tracking those folks we'll give them 3 years worth of blood cancer test screening, and we will be tracking them for cancer diagnosis. And our major endpoint of that study is to understand if we reduce the rate of stage 4 cancers, of cancers that are diagnosed after they have metastasized. And then we have a few other studies that are looking at how this test performs in the real world setting. But I mostly just want you to be impressed with, since, the great Theranos comparison is always made when we talk about blood tests. We, by the end of this clinical development program, will have enrolled over 325,000 patients into these studies. So these are enormous studies that are going to provide very high quality evidence of how these tests really work, but it's just an enormous enterprise, a very expensive enterprise, and we've been very, very lucky to have funding from our investors who see the promise of a test like this to do these studies at the scale they need to be and to do them right. So here's our test, and this is what it actually does. So our blood test, again, it's a single blood test, and I should have brought a box and I could show you, but just imagine a box and it has 2 tubes in it. And the 2 tubes are very special tubes because they can receive a blood sample and then it preserves the blood in such a way that they can be shipped in FedEx at room temperature, which is really, really important because we want this test to be available to everybody. We don't want it to be unduly difficult to draw the blood or have any machines required. All you need to do this test is a phlebotomist to draw your blood and to stick these tubes in their box and get them into FedEx and then ship them to our lab. So that's something we're really proud of, is that you don't need anything more complicated than that. We hope that that will make our test available to people in rural settings, in, you know, international settings. It's a really important part of the test. We sequence all of the blood from, you know, all the DNA in the blood, and there's a lab. We have our own lab in Menlo Park. We also just built a lab in Raleigh-Durham, North Carolina, so that we can run samples on East Coast time because they get there quicker from FedEx. And this is what our test does. So the most impressive thing you might think is that it detects over 50 cancer types. And that is really impressive, but possibly the most important thing about it is that it's got this ultra low false positive rate, because you just don't see this signal of cancer from people that don't have cancer. We have an incredibly low false positive rate. Just for comparison, the false positive rate for something like mammography can be as high as 20 or 30% in young women. So we have really gotten the false positive rate of these screening tests way, way down, because again, when we're testing people who are healthy, one of the most important constructs of cancer screening is that you do no harm and you're not subjecting people to false positives and workups for cancers that they don't have. So our false positive rate is actually lower than 0.5% now. We're pushing it even lower and lower. We're down to 99.6% specificity, which is 0.4% false positive rate. We have evidence of a signal from over 50 different cancer types that you can see here. The ones that do not appear on this list include brain cancer, because the brain has a blood-brain barrier and does not shed its DNA into the blood. But pretty much every other cancer type, including lymphomas and leukemias and heme cancers and solid cancers, we are building the evidence that we can detect it. And we're just learning about what are the conditions under which those tumors are shedding a little or a lot of DNA, and then we can detect that. One of the most interesting things about the test is that it has 89 to 90% accuracy in predicting the location of the cancer. So it has two parts to the test. First, it looks at, of all this DNA floating around, do I see a signal that suggests some kind of cancer, any kind of cancer? Because that's a very particular signal. There would be a lot of mutated strands of DNA at a high copy number, right? So that part is the first most important part of the signal. It's a common cancer signal, and it has to do with the copy number variation and some key mutations that tend to occur in a bunch of different cancer types of genes that control things like cell growth or DNA repair. So it's a very sophisticated signal that incorporates over 30,000 different features from the methylated DNA floating around in your blood, and it first detects the cancer, whether or not you have cancer. Then we can take other features of that signal and look at it's very elegant if you think about it, because all of your chromosomes are designed to copy, to provide the genetic blueprint for all the different tissues in your body. And the way that your cells have the same chromosomes yet are able to produce all the tissues in your body is by turning off huge segments of the genome, and that's called methylation. And so this methylation signal, we are able to figure out pretty well what tissue is producing that signal, where is that cancer coming from, and we give you 24 different choices of where to look for that next, do that imaging or otherwise look for the next cancer. Sensitivity is a measure of how well does this detect cancers, and it's not as high as you might hope or think, like, oh, I want this to detect 90 or 100% of all cancers. We have 68% sensitivity in stages 1 through 3 for 12 cancer types that represent 2/3 of mortality. So these are things like lung, liver, anal, stomach, lymphoma. And the thing that we're learning is that these cancers start shedding a signal, and they are variable at when they start shedding this signal. But if we look at a large population, we tend to find the cancers that are shedding, and we catch them earlier than symptoms. And we're still kind of understanding, how do we push that detection rate higher and higher? But it definitely does not detect, it misses cancers. And when it misses cancers, we suspect, or we know that it's because they're not shedding this signal just yet, and they're going to shed it perhaps as they start growing faster or as they develop a blood supply. So we're learning a lot about the biology of cancer growth and time, and how, shedding this cell-free DNA signal is part of that. Rob mentioned that this is a really growing field. I just wanted to show you all of the different companies and names that you may have seen before that are working on multi-cancer early detection tests, just like ours. So these are all people that are working on cell-free DNA-based tests. Some of them are for multiple cancers at a time, like ours, Thrive, which was acquired by Exact Sciences, who are the makers of Cologuard, are really active in this space, as is the Bay Area companies Adela, Freenome, Delphi, and Guardant. Most of these companies are in the Bay Area. Some of them are elsewhere in the US, but I thought you would be interested to know that the real concentration of this action and activity is here in the Bay Area. We're in Menlo Park. A lot of these folks are in Redwood City and South San Francisco, but a lot of them are here. So what does this mean? If we can develop this blood test and we can get it out being used in the population, this is my contribution to the whole thing, because what I did here with my colleague is say, okay, now we have this understanding of what can these blood tests detect by cancer type and by stage. And if we look at a general population, so we look at the SEER population, which is that cancer registry that I used to help run. So we looked at people age 50 to 79 and they therefore have an average risk of developing cancer. If we model out what could happen, this is what we think it looks like. So we're going to look at the whole United States. Every year in the United States, in this population, we have about 1.3 million people diagnosed with an invasive cancer. Of that, we estimate that about 15 to 20%, 204,000 are being diagnosed with the 5 recommended single cancer screenings that we talked about: breast, colorectal, cervical, prostate, and lung cancer screening. We think Gallery could come in and detect almost double that, so about 420,000 cancers. Gallery is our test, is our product. If we add Gallery to the 5 recommended single cancer screenings, we think we will be detecting over 624,000 cancers, which is about half of the annual cancer burden. And that means that, we could be detecting up to 3 times more cancers early. So we think this is a really, really promising and powerful potential, vision of what we could do. In those models, we don't have any data yet from that large randomized trial. That will be the gold standard data about how these tests might shift the stage distribution of cancers to be earlier. But if we model that out, making assumptions about how long our cancer is sitting there, we could see a huge, the yellow lines on the left are what we see right now across all cancers. And I'm sure you know that, many, many cancers are diagnosed as stage 4, lung, liver, stomach, a lot of GI cancers are not diagnosed until they have already metastasized, many lung cancers. So that yellow bar shows you how it is today, and the purple bars show you what it could look like if we're annually screening people with a test like this that has a performance that we've just started to estimate in our preliminary studies. So very exciting potential here too. But again, this is all modeled data. When we take that stage shift and that real reduction in stage 4 cancer and take it down as low as we think we might be able to, what does that mean for mortality rates? So we think that we could see a major reduction in cancer mortality attributable to this early detection, on the order of 40% of all cancer deaths among people who have a positive screen on the test. And that could avert over 100,000 deaths in the US annually in this screen population of ages 50 to 79. So that's where we're at. We're working together with all sorts of stakeholders. We're working with the NCI, who has gotten really interested in this technology and is proposing their own clinical trial. We're collaborating with them. We collaborate extensively with the American Cancer Society, both scientifically and from an advocacy standpoint. Rob's colleagues that connected us have also an extensive ally development group to work with other nonprofit and advocacy organizations to ensure that people are aware of the unmet need of early detection, and that we do have these emerging technological, to my mind, godsend innovations that are so amazing and so different that we think have this much potential. And this is a real place, and we'll talk a little bit about how your organization is already involved, but we just really haven't had a technology like this, we don't think, in a long time, that we think can, has this great potential. And we really want to make sure that it gets speeded, access and research and access gets speeded here, because cancer is, soon to become the #1 cause of mortality in the United States. In the Bay Area, I would suspect that it already is, because our smoking rates are so low. And, we're just really hoping to get a lot of awareness of both the opportunity, of the extent of the unmet need, of the unacceptable status quo of 70% of all cancer deaths not having anything you can do about, and the potential of these approaches for earlier detection that could bend the overall curve of cancer mortality. I hope that I've convinced you, and I'm happy to take any questions about our scientific rigor. Again, we've been so lucky to have a lot of money invested into us, but what we have done with that is to develop a massive and world-class clinical trial program, including over 300,000 patients, while engaging closely with the FDA, other regulatory bodies, and scientific collaborators, because what we're really doing here is trying to build a brand new paradigm. We want to have a new paradigm for earlier cancer detection that spans all cancer types and is extended to all the general population of, everyone's at risk for cancer. And that's just really different and new, and it just takes a lot of novel thinking. And so it takes a lot of data and a lot of thinking. Again, these partnerships are absolutely critical when you're trying to do something innovative and new. And we're so grateful to have partnerships with you and other leading patient and provider organizations to make sure that this is going to work. And then lastly, I'm going to talk a little bit about coverage and access to these technologies, and what kind of policy is going to be required to support their access. So let's look at that real quick.
Dr. Dur, before we get into
Sure.
that, this is so interesting. We have a bunch of questions, so maybe
Sure.
ask some questions and then we can get into what's happening.
And then we'll talk about the policy stuff.
Yep.
That sounds great.
That sounds great. So the first question is from Craig. He said, how do you see these efforts to find a cure for incurable cancers being impacted by your testing?
So the efforts to find a cure, I can only imagine will be facilitated and synergized by this earlier detection. And that's, again, let me show you that this graph of kind of what's happening. So if we can monitor the signal and detect a cancer earlier, let's just say we can catch a cancer before it metastasizes to regional lymph nodes, or metastasizes, God forbid, into a distant organ like the liver, the lung, or the brain. We know that treatments are much more successful when cancers are more localized. Surgical resection is almost always more successful for earlier stage cancers than for later stage cancers. And we are developing all of these targeted therapies that are more effective when cancers have not spread. So we see our efforts as very synergistic and possibly opening the door to new cures for cancers that are diagnosed so late as to be considered incurable at this time. So we see huge synergy. This is a short presentation, but one of the most exciting things we're doing, and we spent a lot of time and energy on at ASCO, is collaborating with other pharmaceutical companies who have these, curative treatments that they're trying to test in people with early stage cancer, but it's very hard for them to find early stage liver or lung or pancreatic cancer because it's just not usually diagnosed very early. So we're trying to partner with them to make sure that those patients have the opportunity to enroll in trials of treatments that they think are going to be helpful. So I think it's very synergistic and very exciting.
Great. And just for those of you who don't know what ASCO is, ASCO stands for the American Society for Clinical Oncology. They have lots of information on their website. They actually have a whole separate section on their website for patients and family members, which is cancer.net. It's a site I refer to all the time. It has really good medical information in a language that people can understand. So ASCO is, as Dr. Dur said, they just had their big meeting. And if you want to find out more about what came out of that, you can go to cancer.net. Nancy had a question about when will the test, this is a big question, will the test be approved by the FDA?
That's a phenomenal question. So we had what's called breakthrough status, and our other companies in this space also have breakthrough status with the FDA, which means you get to meet with the FDA about your new idea very early on. So we've been doing that for about 6 years, and we've been working with them on, an evidence strategy. I will tell you that I think this is such a different technology that it's so new that like it's just taking a really long time to get everyone on the same page about what is the evidence requirements and strategies for tests like this, because there's really no precedent. There are no other diagnostic tests that read out so many different potential outcomes. It's really more like reading a code, and we're using, the traditional kind of two by two table with a test has one outcome. So anyway, it's going more slowly than we would like, but we are shooting for FDA approval within like 3 years.
Great. And you mentioned that, this question I have actually, you mentioned that you're really focused on people that don't have cancer yet, correct?
Mm-hmm.
And what are there certain tests for people that do have cancer and are looking at recurrence, and are companies that are working on
Yeah,
looking at
so
people
a
already
bunch of these
diagnosed?
companies on the slide I just showed, I'll show that again, but let me show you, like, this is really where cancer is diagnosed right here, but like really you can develop a test for any of these times after diagnosis, for early detection of recurrence, for later detection of recurrence and relapse. So this is a very, very well populated space with, let me just show you some of those companies. Guardant is probably the most famous company that has Guardant 360, which is a monitoring product for different cancer types. Who else? These are all the companies in early, but there's many, many other companies that have products that are called MRD, minimum residual disease, or kind of monitoring products. GRAIL is also working in that space, and I would expect a lot of these other companies will work on kind of both sides, on the early detection and on, on the post-diagnosis utility of these signals.
Great, thank you so much. And I would love, we have a few more questions, but I'd love just to have some, if you can talk about what is happening on the legislative front, because
Sure.
Our organization supports your efforts, and we will be putting out information to all of you about how you can, the question about the FDA is very relevant, about how you can make an impact and
yeah,
sure
so let me talk through that. So cancer, I think the kind of regulatory or medical reimbursement kind of practices are really different for cancer screening. And that is because any kind of preventive service or early detection cancer screening device or activity is intended for people who do not have a disease, right? It's intended for the general population who may or may not have a disease. And therefore, this whole idea of how do we ensure that the harms do not exceed the benefits of this test is critically important. So they are regulated very differently than drugs or other devices that are intended for people who are known to be sick. Those have lower bars for kind of FDA and other evidence. So as such, like, it's been very difficult to get Medicare to cover cancer screening. And if you look in the past at cancer screening that has been guideline approved by the medical guideline writers, but yet we could not get the insurance companies and Medicare to cover these things until Congress said, look, we're just going to enact a law and make sure that insurers and Medicare cover these things. So in 1989, they required that pap smears be covered. In 1990, they required that mammography be covered. In 1997, they added prostate and colorectal cancer screening. And then as part of the Obamacare 2008 Medicare Improvements for Patients and Providers Act, then they started to tie Medicare coverage for preventive services to this review, which is called the United States Preventive Services Task Force, USPSTF. That is a quasi-governmental agency that reviews the evidence for things like mammography and statins for heart disease and aspirin for heart disease, and like any kind of preventive recommendation is reviewed and recommended by the USPSTF, and they give it an A, B, C, or D grade. And any activity like mammography or colorectal cancer screening has an A or B recommendation. Prostate cancer now has a C recommendation, which means we're not going to recommend it for everyone. You have to go talk to your doctor about it. So the point is they had to add coverage for USPSTF A or B recommended things through congressional action. So as such, just because we think that our technology and this technology that's being built up by so many other amazing companies has so much promise, we have initiated together as MCED companies a piece of legislation called the Medicare MCED Screening Coverage Act. It has already been supported by 248 bipartisan lawmakers. Some of the first to sign on to it are shown on the screen here, but you can see they're from all over the country. And what ties them together, what probably makes them known to you, is that they are all either cancer survivors or huge cancer advocates. So they're really excited about new technologies that are broadly have broad potential in cancer, and that is why they're signing this bill. And so we have asked you and over 400 groups for your support and your endorsement of this legislation. And we, as you can see on the right side, we have gotten very broad letters from a whole variety of groups, including Cancer Support Community. We're so thankful. And single cancer, advocacy groups too, like Komen and PanCan and Colorectal Cancer Alliance, and many of the cancer advocacy groups that focus on one cancer type are particularly excited about this legislation and this approach, because they know that the cancer that they're interested in, like pancreatic cancer, is so rare that they're never going to have screening unless we have some kind of multi-cancer screening approach, because it's just too rare of a cancer to be able to screen for it broadly in the population. So we're really lucky to have had phenomenal reception of this idea in both the Senate, the House, and with our stakeholders in advocacy organizations.
Great, thank you so much. And it's almost 7 o'clock, and I want to thank you so much, Dr. Clarke Dur. This is so much information to distill down into 35 minutes, but it's incredibly exciting information. And I want to thank all of our members and supporters for being here today. We will continue to offer these types of programs. Just be on the lookout to thank you for your support and to help educate you about what's going on. And hopefully we'll be able to do these in person. We wanted to do this one in person, but most people did not, for obvious reasons, will prefer to do it virtually. We'll always have a virtual option, but I'm hoping next time in a few months we can actually gather in person and I could see all of you and talk to all of you. If you have any questions, please feel free to email me. If you have any more questions for Dr. Clarke Dur, I'm happy to pass those along to her as well. And if you have any suggestions for topics that you'd like to hear about, please let us know as well. So it's so nice to see all of you on Zoom. Thank you for coming, and really appreciate your being here today, and hope it was interesting.